Partial fraction decomposition. So remember that our goal here is to break this fraction up into smaller, simple fractions. The idea, of course, is first that we want to make sure that the power on the x on top, which happens to be a 1, is lower than the power of our x's on the bottom. On the bottom we see that we have degree, 5, and on top we have degree 1. This means we do not need to divide first because this fraction is already simplified for us regarding dividing out any pieces that we might have. Now we want to break this piece up into the factored pieces on the bottom of this fraction. If the bottom, the denominator, were not already factored, we would do that also before beginning this process. Since it's already factored, we can begin here by taking our first factor, the x squared plus 1, and noticing that it has a power of 2 on the outside. So as we use this one first, this outer shell power needs to be basically represented twice. First we'll start with 1, then we will represent it again using the outer power of 2. So basically we count up to this outer power by repeating the x squared plus 1 factor that we have here. So let's see, the shell has been counted 1, 2, so that's been taken care of, and we repeated that inside stuff. And then we have one final factor in that denominator, x subtract 1. Now that we have our fractions represented on the bottom, let's set up the tops appropriately. The way we weight these, remember, is if we have like an x squared, we're going to start with 1 power down, meaning a x to the first, and we always count down, so ax plus b, so count down from x to the first to a piece having no x's. The next one, we'll start with the next ABC letter, we'll say c. This one also is going to be x squared because we are just using the stuff inside now, the actual factored part, not the outer shell part. We already took care of the shell part when we repeated this piece 2 times. So we will have just a regular cx because that goes with the x squared on the inside here. And then we will also count down from x to the first on top to no x's on top. So we have plus d. On our last piece, we just have a simple x subtract 1. That x is to the power of 1, so we're going to add a letter on top that has no x on it. You know, x to the 0 basically. So let's see, I have a, b, c, d. We will add an e here. Remember that our goal is not solving for x. Our goal is to solve for our ABCs so that we can now represent this initial fraction as 3 separate fractions. Let me rewrite what we have now, because at the very end, when we put our answers back in, it's always good to keep a nice original copy of what we had. Also, this gets kind of messy because our next strategy is going to be getting common denominators. Okay, so on our first fraction, please notice that we have x squared plus 1. We are missing our second x squared plus 1. And again, we're trying to make these all match. It's always a good idea just to look at the original. That's what we want all of these denominators to look like. So it's missing the x squared plus 1. It is also missing an x subtract 1. So I'll add that on top as well. Okay. On our next fraction, we already have 2 of the first factor, the x squared plus 1. We're only missing the x subtract 1 this time. And on our last piece, here with the e, we were just missing the x squared plus 1 squared. Please remember that this is all equal to the original stuff. We're just rewriting that original fraction into broken down fractions so that we can have simplified fractions, or more simple fractions for calculus later. Okay, now that we have our denominators matching on both sides of an equals, we are allowed to cancel off those denominators. Since we are not solving for x, we don't need to write any restricted stuff regarding those x variables that we just now canceled. Instead, we're going to focus our attention on foiling and trying to clean up the numerators on the right-hand side. Notice on this last piece that I'm going to go ahead and write the x squared plus 1 2 times, just to kind of remind you all that we do not want to share that exponent of 2 through on the x squared plus 1. Because of the addition, we have to actually FOIL there. Okay, now let's see. I'll begin by FOILing the easiest thing on this first little set of stuff we have to deal with. So I'm going to FOIL these two. First would be x squared times x. That's x cubed. Outer is minus x squared. Inner is plus x. And last will be negative 1. Going to write that in parentheses because we still have the ax plus b to multiply there. I'm going to kind of just move across and just keep doing little things to each step until we're fully cleaned up or simplified here. So now I'm going to FOIL over here. Let's see, we have cx being multiplied by x. That will give us cx squared. Outer we have negative cx. Inner will be d times x, which is dx. And then for last we have subtract d, or a negative d. Okay, over here on the last piece, you can do whatever simplification step you prefer. I personally am going to go ahead and share this e into the x squared plus 1. I'm choosing this route because I've noticed it's really tempting for students to put e everywhere. But remember, we are multiplying, so you only need to use the e one time through multiplication. So I'm going to take care of that now. That will give me ex squared plus e and x squared plus 1. Back to the left-hand side now. Let's take care of the ax plus b multiplying through on the x cubed, x squared information here. So we have ax times x cubed is ax. We add powers to the fourth. Ax multiplied by negative x squared is negative ax to the power of 3. Then we have plus ax squared and subtracting an ax. Now let's share the b through. We have b being multiplied by x cubed, so that will be plus b x cubed. The next piece gives us subtracting b x squared. Then we have plus bx and subtracting b. The next piece that we have, the cx squared stuff, I'm going to rewrite that so we don't lose track of it, but please notice that it's already okay. It's already been multiplied out fully. I'm going to actually wrap, which I don't usually do, but since I'm working on paper here, I will do that. I may have written smaller if I wasn't trying to kind of illustrate this for you all. Let's see, minus d. And then here we're going to go ahead and FOIL this last little set of data we've got here. So the first two we have ex squared times x squared will give me plus ex. Adding powers gives me to the fourth. Outer we have addition there because positive times positive, ex squared. Then for the inner we also have plus ex squared. And then for the last we have plus e. Okay? And all of this stuff is equal to 2x. So now we are to the point where we're going to try to solve for the ABCs by going into what I like to call the matching game. So what I'm going to recommend that we do is that we rewrite this 2x a little differently. Please notice that we have here x to the power of 4 is our highest x term over here on the right-hand side. So what I usually like to show people is to put every single power that we have present on the right on the left-hand side. So I'm going to write 0x to the 4th plus 0x to the 3rd plus 0x squared plus 2x, and then I'll put plus 0 to fully count down. So we'll need that in just a second as we do the matching. Okay, which we're doing now, so let's see. Okay, so the first thing we have is the x to the 1st. During this matching game, remember, we are just matching coefficients. We do not keep the x's on this information. The x's just help us with the matching game, so we know which stuff goes with the x to the 4th and which stuff came from the x to the 3rd, etc. So here I have 0 on the x to the 4th. So now when I go over here, I'm going to make boxes around anything that has x to the 4th beside it. So scanning left to right so that I hopefully don't miss anything. Let's see, it looks like down here I have a positive e also. What that means so far is that we have positive a plus e is equal to 0. The next thing we have is x cubed, so I'll put a double line to that to signify the x cubed pieces as we match those. So we have negative a on that x cubed. Scanning from left to right, I see a positive b. Continue scanning. Do we see any other cubes? No. So all that we have here would be negative a plus b being equal to 0. Again, notice we do not keep the x's. We only take the coefficients because we are matching and saying all of the cubes had better add up to be 0. Everything that had an x cubed beside it. Next piece, we still have a 0 for our x squared. So that's going to include that a right there. Scanning left to right, there's a negative b. There's a positive c. There's actually 2 positive e's. Okay, so what we have here would be a subtract b plus c, and then we have 2 e's. You could actually write it as e plus e if you really wanted to, but we know that's going to go together and become 2 e's. Okay, and that is all equal to 0. Next we have our 2x. I'm going to use a triangle this time. So we are matching things that have a plain x to the 1st power. So here we have negative a, there's a b, negative c, d. Okay, that's everything we have for the x's. Okay, so again we're doing triangles. That's negative a. Now we have positive b, negative c, positive d, and that was everything that we had there. So that's all equal to the number 2. And lastly, we are finally almost done with the matching game, even though I know you guys are loving it. Okay, now we have 0. Just standing in place of a plain number with no x beside it. So let's see, do we have any plain numbers here? Any pieces that do not have an x at all? There's a negative b. There's a negative d. There's a positive e. Okay, so what that means is, let's see, negative b, negative d, positive e will all go together to give me a 0. Okay, that was the complicated part. At this point, all that we do is put this into a matrix. So we have these letters, A, B, C, D, E, and then we have the equal to information, of course. We have 1, 2, 3, 4, 5. Okay, so on the first one, please notice we have 1A. By first one, I mean this top equation here. We have 1A. We do not have any B's, no C's, no D's, 1E, and it all will equal 0. On the next one, we have negative A, so negative 1. We have 1B, no C's, no D's, no E's, equal to 0. On the next equation, we have 1a, negative 1 for the b, positive 1 in front of that c, no d's, 2 e's equal to 0. On our next equation, negative 1, 1, negative 1, 1 for that d, still no e's equal to 2. And then on the final equation, we have no a's, negative 1 in front of that b, no c's, negative 1 is the coefficient on that d, positive 1 is the coefficient on the e, all equal to 0. So using our calculator or whatever technology device you use to reduce down your matrices, let's do the reduced row epsilon form. Let's find that form of the matrix. Okay, so here I'm showing you the reduced matrix that goes along with this problem. If you were using a graphing calculator such as TI-84, remember, when you see an arrow on your calculator screen, it does mean that you can scroll. So I had to scroll down to see all of the data that I got from this. And I also chose to hit math fraction to convert the decimals into fractions, even though we really should have known what those decimals were. It's just a good practice to give you a nice, clean-looking matrix here at the end. So we have here on the first row that 1a is equal to negative 1/2. We have that b, the one with the b is lining up with the negative 1/2 also. We have that c is equal to negative 1, that d is equal to 1, and that e is lining up with the 1/2. So let's plug that back into our original breakdown format up here at the top that we had. So let's see. Please notice that the a and b both have 2 as their denominator. So this makes our lives very easy, because what we will do is, in place of the a up here where I circled at the top of the page, please notice, I'm going to just put the numerator on that fraction. I'm going to just put the negative 1. In other words, we have negative x plus, now in place of the b, I'm going to also put, I should have not put a plus, but it's okay. I'm going to also put the negative 1. This is all over. Because both of those were halves, I'm going to put the 2 on the bottom, and then we had x squared plus 1 on the top. So I just now used the first fraction at the top of the page here. And I replaced the a and the b with the negative 1s on top and the 2 on bottom to represent negative 1/2 for each of those on that fraction. Now we have the c and the d coming up. C is negative 1, giving me another negative x. The 1's just kind of implied, remember, in front of the x. Then for d, we have a positive 1 this time, so I'll say plus 1 over, and let's see, there were no fractions this time, they're just regular whole numbers, so I'm going to keep the denominator exactly as it was to begin with. The x squared plus 1 squared. As you back substitute here, be very, very careful. You do not want to sub the wrong numbers in for the wrong letters, because it makes a really big mess and it really means nothing. It does not give you anything close to a correct answer. For the final fraction, we're putting the e in. E was equal to 1/2, so I put the 1 on top, the 2 on bottom, and there we have our fractions. Remember, we said in class that you can actually put this circled stuff right here, this new solution in for maybe y1 in your calculator, and you can also do that with your original fraction, and you can verify that you actually have the exact same representation happening, because you'll be getting outputs for y1 and y2 that are the same. You'll also be getting the same picture on your calculator. Okay, that's it.